Hello, class. Welcome to today's lesson. Before we get into our lesson on logarithms, I'd like to just make sure that some things about the grades in OnCourse are clear. So when you check your grades in OnCourse, anything where the grade is based on completion or effort, that'll be indicated in the title of the assignment. So we do sometimes have graded assignments that I actually graded, marked right and wrong, things like that. But most of the daily assignments are based on the fact that you completed it with a full effort. So when you look at your grades on those types of assignments, if you see full credit, like a 3 out of 3, 2 out of 2, 4 out of 4, that means you're all set. I checked it, I marked you present, and you're good to go. If when you look at something that's graded based on completion or effort and you see a 0, what that indicates is that I did not receive that assignment from you. So if I did not get the assignment from you, you're probably marked absent for that day, and I have definitely contacted you. So check your email, because you probably have an email from me or a personal message through the Google assignment. And very important, if you are missing an assignment and I contact you and you make it up, you must contact me to tell me that you made it up, because a lot of the programs we're using do not tell me, they do not send me a notification if a student submits something late. So if you do make something up, the only way I'm going to know is if you contact me and tell me. Another possibility for something that's graded based on completion or effort is you see a score like this. 2 out of 4, 3 out of 4, something that is not 100%. What that indicates is that I contacted you and asked you to redo part of the assignment or resubmit it or to do some other task. So what that would indicate is when you submitted the assignment, I wasn't quite sure that you had everything down. So I asked you to do a little more. And again, check your email, because I'm not going to put it incomplete. I'm not going to give you partial credit for something that's graded based on completion without telling you. And last possibility in OnCourse is if you see something that says no grade, all that means is I haven't had a chance yet to either grade it or put the grade into OnCourse. So if it says no grade, don't worry about it. It just means I haven't gotten to it yet. Okay, so hopefully that clarifies some things in OnCourse for you. And let's get to today's lesson. Today's lesson is about graphing logarithmic functions. We're going to focus on graphing today. So if you're in my pre-calculus class, this is section 3.2. If you're in my Algebra 2 class, this is section 6.4. So what we're going to do with 4 examples that we're going to do today, we're going to graph the function. We're going to make sure 5 points are clear, as well as the asymptote. And we're going to give the domain range and equation of asymptote. So the first one we're going to do is the graph of log base 4 of x. Now, log base 4 of x is the inverse of the exponential function y equals 4 to the x. So this and this are inverses of each other, because if we take the x and the y from the exponential and switch them, we get x equals 4 to the y. And then if we rearrange the base, the exponent, and the other guy, we get this equation right here. So these two are inverses of each other. The reason I'm reminding you of that is because that relationship can help you graph log base 4 of x. Because if I make a table of values for y equals 4 to the x, I can do that pretty quickly in my head. We need 5 points. That's what the directions said. So let's use 0, 1, 2, negative 1, negative 2. 4 to the 0 is 1. 4 to the first is 4. 4 to the second is 16. And 4 to the negative 1 is 1/4. And 4 to the negative 2 is 1 over 16. And since this is the inverse of that exponential function, we can create a chart pretty quickly by just reversing the x's and y's. So we're going to have 1, 0, 4, 1, 16, 2, 1/4, negative 1, and 1/16, negative 2. So to graph log base 4 of x, we're just going to plot these points. So I'm going to plot 1, 0, that happens to be an x-intercept, 4, 1, 16, 2 does not fit. That was not part of my plan. Let's continue. 1/4, negative 1 is another point. We're going to estimate that location. And 1/16, negative 2 is another point that we're going to estimate that location. So if we connect the dots, the graph goes up to the right forever, not very steep at all, because we'd have to go all the way out to 16 just to get up to 2. And it's going to drop down very rapidly toward the y-axis, because that's going to be the vertical asymptote for us. It's hard to show the vertical asymptote sometimes when it overlaps an axis. So that's why I'm extending above and below. Now the directions here said at least 5 points, and I did not realize when I made up the problem that we can only fit 4 of the ordered pairs we found. No big deal. That won't happen to you in the classwork that you're going to do on your own today after the Edpuzzle. So we'll just continue on our way. And the next thing I want to do is give the domain, range, and equation of asymptote. If you look at the graph, the domain is anything that's bigger than 0, but not including 0, because the vertical asymptote is the y-axis. The equation is x equals 0. So we don't actually use x equals 0. That's why it has to be parentheses and not a bracket. The range, on the other hand, the graph goes down forever and it goes up forever. It goes up slowly, but it goes up forever and ever and ever and ever. So the range is all real numbers. And that's our first example. For example 2, we are going to graph log base 4 of x minus 2. So this is my log base 4 graph. Because that minus 2 is inside the parentheses, it represents a transformation. Is it a horizontal shift or a vertical shift? This is a horizontal shift right to of the log base 4 graph. So good news, transformations work the same way they always have. Transformations work the same way for exponential functions and quadratic functions, your parabolas, your absolute value functions, your square root functions, your cubic functions. The transformations still work the same. So as long as you can graph this basic one, you can then just move it right to. So what we would do is we would make that table again, but we just made that table. So let's just sneak those points here. Since we just made that table for 4 to the x, and then we reversed them to get the points for log base 4 of x, I'm not even going to bother to rewrite all those points. I'm just going to go ahead and plot them. So I'm going to steal those points from our previous work. So I have 1, 0, 4, 1. 16, 2 doesn't fit on the graph. You'd have to extend it to fit it. 1/4, -1. And 1/16, -2. So the graph goes up to the right very slowly. Drops down toward the y-axis because that's the vertical asymptote. And this is the first graph. This is not the final graph because we still have to move it right too. So if you want to draw in the asymptote, you can, or if you want to wait and just draw it in the final one, up to you. I would say since you guys are beginners, I would draw in the asymptote now for this one. Okay, so that's our log base 4 graph. What we have to do with that graph now is move the entire thing 2 units to the right. So what we do is we take the asymptote, we move that 2 units to the right. The asymptote moves, the vertical asymptote moves when you have a horizontal shift because all the points move 2 to the right. So this point right here that I had to estimate is going to move 2 to the right. It's going to be really close to that asymptote. This point here is going to move 2 to the right. This point at 1, 0 moves 2 to the right to 3, 0. This point that was 4, 1 just moves 1, 2, 3. You can just count it and move it 3 units to the right. And then the graph that we're going to draw should have the same shape and same steepness as the original. So we're going to go up pretty slow to the right, but it does go up forever. And then it's going to drop down very rapidly toward that vertical asymptote. You do not want to point here. So if you find it kind of looks like pointy, like a corner of a box or something, try to go in and round it out because it should be a smooth graph. We call that a smooth graph. So this is my final graph, the red one that I have here. If you have a different color, you might want to use a different color or highlighter. Some of my students like to use a highlighter to show their final graph. Or you can just label that it's your final graph. So this is our log base 4 graph moved 2 to the right. The domain of this graph we can get by looking at the function. If we look at the function, the domain is anything that's bigger than 2 because we go from 2 to infinity. 2 out to the right, but not including 2 because that's where the vertical asymptote is. And then the range is going to be all real numbers because this graph goes down forever and it goes up forever. It goes up slowly, but it goes up forever and ever and ever and ever. Okay, and that's example 2. I think 2 more of these examples will be sufficient. So let's move to example 3. So for example 3, same directions, but new base graph. See how it's log base 3 of x. So I can't use the table that I used before. So my suggestion is we start with the exponential function, because that one's pretty easy to do in our heads. And then since we know that these are inverses, we can just switch the x's and y's. And then we'll handle the negative out front. The negative out front is going to be a reflection over the x-axis. Okay, so I want to start by getting this basic graph down, the parent function, sometimes people call it, or the common function. And to do that, I'm going to start with this guy, because I can figure out that table in my head pretty quickly. Okay, so since we want 5 points, and this time we can actually get 5 points because the base is 3, I'm going to pick 0, 1, 2, negative 1, negative 2. So 3 to the 0 is 1, 3 to the first is 3, 3 to the second is 9, 3 to the negative 1 is 1/3, and 3 to the negative 2 is 1/9. Now I don't want to plot those points because I'm not doing the exponential graph, I'm doing the log graph. But the reason I took those points is so I could flip the x's and y's. And then plot these. So I'm going to plot 1, 0, 3, 1, 9, 2, estimating where 1/3 negative 1 would be, and estimating where 1/9 negative 2 would be. This graph goes up to the right, down to the left, approaching that vertical asymptote but not crossing it. Vertical asymptote right now is the y-axis. And this is our log graph. So that is log base 3 of x. What we need to do now is use this negative that's out front. When there's a negative out front, what that tells us is we're going to do a reflection over the x-axis. So what we're going to do is take every point and do a mirror image. So since this point is 2 units above the x-axis, it's going to flip down and be 2 units below. This point is 1 unit above, it'll flip down and be 1 unit below. The point that's on the x-axis, that x-intercept at 1, 0, is going to stay right where it is. This point that I estimated at 1/3 negative 1 will flip up. This point that I estimated at 1/9 negative 2 will flip up. And how about that vertical asymptote? Is it going to stay in the same place, or is it going to move when we reflect over the x-axis? It's going to stay in the same place because the graph is still going to approach the y-axis, because this part of the graph is going to go up, and instead of dropping down very rapidly toward the y-axis, this part's going to go up and approach the y-axis. And this part will come down to the right. Not very steep, but it is going to go down forever. And these should look like mirror images over the x-axis because we took the basic log graph and flipped it over the x-axis. Take a moment and find the domain and range and equation of the vertical asymptote for the red graph, which is my final graph. I'm going to label it with the equation. The domain should be 0 to infinity, parentheses on the 0. The range is negative infinity to infinity, and the vertical asymptote is x equals 0. And we have one more example to do today before you go and do some practice on your own. And the example that we're going to do for number 4 is log base 2 of x with a plus 5. So what we're going to have to do is graph log base 2 of x, which is different than the other ones we just did. Okay, so we're going to have to graph log base 2 of x. And then the plus 5 is going to be a vertical shift up 5. So once we get that basic log graph, we're going to move it up 5. And I can tell this is a vertical shift because if you look back at the previous examples, to have a horizontal shift, it would have to be inside. So just to show you the difference here. So here, this would be a horizontal shift because that plus 5 is inside of the parentheses. When you have log base 2 of x with a plus 5 at the end, that would be equivalent to saying that you have log base 2 of x and then a plus 5 at the end. So if there are no parentheses written, it's only that first term that's inside the log. So that's why this one's a vertical shift up 5 instead of a horizontal shift. You might want to make some note of that on the side because that can be tricky to tell. Okay, so I think you can try this one without me. Okay. So if you tried this one without me, you graphed 2 to the x first, I hope. The inverse of y equals 2, you don't graph it, I'm sorry. You made your table of values. The inverse of y equals 2 to the x is y equals log base 2 of x. The inverse of that exponential function is the log function. Exponential function and log function are inverses. Just a quick reminder, because if you were to graph y equals 2 to the x, remember it looks like this. And then the inverse would be the reflection over the line y equals x. So the exponential function with the base of 2 is the inverse of the log function with the base of 2. Okay, but we don't have to graph the exponential function right now. We want to graph that log function. So once you have your log function graphed, we now want to move this graph up 5. So when I move the graph up 5, the vertical asymptote is going to stay in the same position. Because if you take the y-axis and you try to lift it up, so picture picking this up. So pick this up and move it up 5 units, it stays in the same place. So the asymptote does not move. The asymptote is still going to be x equals 0. But this point here will move up 5. So 1, 0 will become 1, 5. No longer an x-intercept. This point at 2, 1 will move up 5 to 2, 6. And this point at 4, 2 will move up 5 to 4, 7. This point that I estimated at 1/2 negative 1 is going to move up 5 to 1/2 4. And this point that I estimated at 1/4 negative 2 will move up to 1/4 negative 3. And the graph will go up to the right very slowly. You want to maintain the same steepness you had here. This graph goes up forever, but not fast. And then it drops down very quickly toward that vertical asymptote. Technically, the graph never hits the vertical asymptote, but when you go to draw it, you're probably going to bump into it, and that's okay. Just realize that the graph doesn't actually cross that asymptote because the domain is 0 to infinity. And then the range is going to be all real numbers again. So there's my final graph of log base 2 moved up 5 units. That concludes today's video, and you can go ahead to the next part of the assignment to do some practice on your own.